Good morning, students. This lecture is in continuation with the previous lecture, that is the unit 1, chapter matter, properties of matter. Today we will discuss the topic of latent heat. Now, latent heat. What is latent heat? It is the energy absorbed or released by a substance during a change in its physical state that occurs without changing its temperature. When a change in the state of material occurs, the temperature usually remains constant, but heat is absorbed. This heat, which results in the change of matter without increasing the temperature, is called as latent heat. When this heat results in the change of state from solid to the liquid state, this is called as latent heat of fusion. Understand? What is latent heat of fusion? When this heat results in the change of state from a solid to a liquid, it is called as latent heat of fusion. For example, the heat required to change ice to water at 0 degrees Celsius. It is the example of latent heat of fusion. Likewise, the latent heat of vaporization. What is latent heat of vaporization? The latent heat associated with the melting of solid or freezing a liquid is called as latent heat of fusion, and that associated with the vaporizing of liquid or solid or condensing of vapor is called as latent heat of vaporization. Okay? For example, heat required to change water to vapor at 100 degrees Celsius. Heat required to change water to vapor at 100 degrees Celsius is the latent heat of vaporization. Okay? Next topic is vapor pressure. Vapor pressure of liquid is the equilibrium pressure of a vapor above its liquid. That is the pressure of vapor resulting from evaporation of a liquid or solid above a sample of liquid in a closed container. This is called as vapor pressure. Means, I'll explain you. When a liquid is kept in a closed evacuated container, the molecules from its surface continuously leaves and go into the free space above it. This is known as the process of vaporization. Okay? Some molecules, however, return to the surface depending upon the concentration of the vapor. Okay? This process is called as condensation. Eventually, a condition of the equilibrium gets established when the rate of escape of molecules becomes equal to the rate of return. Means, there is an equilibrium between the rate of molecules that escape from the surface and the rate of molecules that return on the surface. Okay? The vapor is then said to be saturated, and the pressure exerted by the vapor at equilibrium is known as vapor pressure. Now clear? For example, substances diethyl ether, its vapor pressure at 25 degree is 0.7 atm. Likewise, bromine, ethyl alcohol, water. You can see the vapor pressure of liquid varies with its temperature. Means, when the temperature is increased, eventually the vapor pressure is also increased. As the temperature is raised, more of the liquid goes into the vapor state and the vapor pressure increases. As the temperature is raised further, the density of the vapor increases while that of liquid decreases. Eventually, the densities of both the phases becomes equal and the two phases cannot be distinguished. The temperature at which this happens is known as critical temperature, and above this temperature there is no phase. Okay? Clear? Now this is a graph between the vapor pressure and temperature. It shows that with the increase in the temperature, the vapor pressure gets increased. Next are factors that affect the vapor pressure. First of all, surface area. The vapor pressure of the liquid pressure. The vapor pressure is the equilibrium pressure where the rate of evaporation is equal to the rate of condensation. Since the scaling factor is the same, the vapor pressure is independent of surface area, means it doesn't depend upon the surface area. Second is type of molecules. The type of molecules that make up the solid or liquid determines its vapor pressure. If the intermolecular forces are strong, the vapor pressure will be low. But if the intermolecular forces of attraction are weak, the vapor pressure will be high. Okay. Third is temperature. As I have already told you that with the increase in the temperature, the vapor pressure gets increased. Means at higher temperature, more molecules have enough energy. They escape from the surface of the liquid or solid. Okay. At the lower temperature, few molecules will acquire the sufficient energy to transfer or escape from the liquid to the solid. So with the increase in the temperature, the vapor pressure gets increased. More the temperature, more the vapor pressure. Fourth is intermolecular forces of attraction. As I have already told you, those liquids in which intermolecular forces are weak show high vapor pressure. Next topic is sublimation, critical point. Now sublimation. What is sublimation? It is a change of state from a solid to gas without passing through a liquid state. Means sublimation is change in the state directly from solid to the gaseous state without converting into the liquid state. For example, you can see carbon dioxide. It's the example of sublimation. Okay, this is the phase diagram. Students, you can see in this slide. This is a phase diagram, okay, between the pressure and the temperature. Okay, here three states exist, that is solid, liquid and gas. Okay, now in the graph, this line shows that the equilibrium exists between solid and the liquid. ये equilibrium की condition है. यहाँ पे solid और liquid दोनों equilibrium में है. Left side में solid है and to the right side liquid state exists. Now this line in this graph shows the equilibrium between the liquid state and the gaseous state. Means this is a equilibrium condition between the liquid state and gaseous state. Here liquid state exists and here the gaseous state exists as it is written over here. Okay, now this point, ये जो point है, ठीक है, इसको हम बोलेंगे ट्रिपल पॉइंट. जो ये लाइन है, ठीक है, this line is the shows the sublimation. Means here the solid gets directly converted into the gaseous state without converting into the liquid state, and this point is called as triple point. ठीक है, triple point. Triple point means it is a condition in which the solid is in equilibrium with the gaseous state. Okay, where all the three phases of the material are in equilibrium with each other. That is known as the triple point. Okay, now phase rule. Phase rule is the rule relating to the possible number of phases, constituents and degrees of freedom in the chemical system. This rule was proposed by William Gibbs in 1876. What is phase? Phase can be defined as a homogeneous part of a system having all the physical and chemical properties. The properties are identical throughout. The system may consist of one or two or more phases. Okay. Now single phase system क्या होता है? Single phase system is a system in which only liquid water exists. Means a system containing only liquid water. That is called a single phase. Okay. And two phase system, a system containing liquid water and gas. Means two phases हैं इसमें, liquid as well as gas. Now three phase system where water, steam and solid ice exist. Three phases exist na, solid, liquid and gas. This is called as triple phase. For a system at equilibrium, the phase rule relates P plus F is equal to C plus 2, where P is the number of phases, F is the number of components making up the phases, and here C is the number of independent variables or degrees of freedom. Okay, that's all for today. Thank you.